properties of logs. This is review for everybody. You did this in Algebra 2. It is expanding and condensing logarithms, and part of that on your no calculator quiz will be using those properties to be able to find values. The warm-up I have, you don't have real quick, but I just wanted to one more time go over this. You're going to need to be able to graph these. I wanted to insert a graph and I was having trouble finding that, so we're going to fake it. 3 to the x. Somebody give me some numbers we could put in there. 1. 3 to the 1 is 3. 2. 0. 3 to the 0 is -1. Okay. So then, what shape should this turn out to be? Yeah, a swoopy up like this, right? When you plot those. Okay. And so the domain will be, you're not going to let it touch the x, right? And you're going to have a y-intercept here was 0, 1. I didn't graph it otherwise, but so this is -infinity to infinity, and the range, guys? Yes, it can't be negative. The asymptote is the x-axis or y equals 0. Either one is fine. And the only intercept was 0, 1. Now, what happens when I go to do the log? Rewrite this. Did you learn anything yesterday? How do you rewrite this? 3 to the y equals x. Now, when I rewrite it and I want to find ordered pairs, I just put them in for y. Does that make sense, guys? Because it says 3 to some power. So if I put in a 1, I'll get out a 3. If I put out a 2, I'll get out a 9. A -1, 1/3, and a 0 for y would be, okay, what's that going to look like? Do you remember? What quadrants is it in? Goes 1, 2, 3, 4, if you don't remember how they're numbered. No. Okay, if I plot the points real quick, 3, 1, all the way out at 9 before it's up to 2, 1, 0 is there, 1/3 is -1. That's 1 and 4, okay? It's over 1/3, but down 1, okay? That's the shape, okay? You have to know that or you're going to end up graphing it wrong. The domain is
0 to negative.
Okay, the asymptote is x equals 0, or the y-axis this time, right? Because they're inverses, remember? And the intercept is 1, 0. Okay, I'm sure this won't work, but if I tried to move this over here, oh, it didn't do too bad. They should be reflected across this line, remember? Okay, now on the quiz, I don't think I gave you the same base for both problems. So that won't be exact inverses. Do you know what I'm saying? It might be the log of 2, the log base 2, but the exponent might be 4 to the x. So they're not necessarily exact inverses. But all right, I just wanted to revisit that one more time. Properties of logarithms. This is based on properties of exponents. Remember these guys? So if you had something like this, you would do what with those? When you were multiplying, it meant you ended up adding the exponents. Everybody with me? That's because multiplication is really repeated addition, right? Do you remember that from when you were a kid? Okay, this, these aren't above the right ones, okay? This goes with this. The quotient property said when you were set up as a divide, what did you actually do with those exponents, guys? This became x to the 5th. This became x to the 4th. You would subtract, right? Remember this? okay? And then this one, if you had a power to the power, you did what? You multiplied, okay? Now, you have to be really clear on these two, okay? That multiplying means adding and dividing means subtracting, because we're going to do them the other way around. The product property, guys, says that when you have something like log of 4x, multiplication, you can separate that into the log of 4 plus the log of x. Do you remember that from last year at all? Yeah. Okay, multiply, add, go together. Divide, if you have the log of 7 over n, you can rewrite it as the log of 7 minus the log of n. Okay? And the power property is if you have the log of x cubed, that you can move that cubed out in front and make it 3 times the log of x. We talked a little bit about that one yesterday. All right, so this is what it looks like at the top of your notes. Any questions? All right, so do you have these two? No? Just help me out real quick. This is all multiply, so what are we going to do with them all? Yeah, you got to keep the base. Unfortunately, that's a lot of writing.
X plus log 8 and log 8y.
Now, yeah, we can move that squared, and that's something you have to do to where? In front of just that one, yep. Everybody good? All right, what about this one? Log base 6 of, and I'll go ahead and write this, and then we'll move them, but divide means subtract. Log base 6 of y to the 5th. Everybody okay? And then we move this in front of this one and this one in front of that one. So I'd have 4 log base 6 of x minus 5 log base 6 of y. All right, let's try some that I hope you do have. Yes? Oh my goodness. Okay. This is actually an evaluate question like I could put on a quiz. Okay? I don't think I want to move this around, do I? Right now, it says 3 times the log base 2 of 8 plus 5 times the log base 2 of 4. If I move that, I'm going to have an 8 to the 3rd, right? If you don't have a calculator, do you want to do 8 to the 3rd? How about if you just think about what power this is? This means 2 to some power equals 8, right? What is that? 3. So this evaluates to be a 3. There was already a 3 out front. Plus 5 times, what is this? This means 2 to some power equals 4. So that evaluated down to a 2. So what do we get? Okay. So I'm not sure what properties of logs we had to use to do that. We could have done that question yesterday, I'm thinking. Right? If it had started out with a 3 up here, we certainly could have moved it out there to make it easier, right? Rather than deal with an 8 to the 3rd. But all right, this is an expand that's done for you. Please notice that they did ln of, and they thought of this as 8 times x to the 5th over 3 times y to the 2nd. But this is a huge issue, guys. Students get this wrong all the time because they write this. ln of 8 plus is times, times is plus. 5 ln of x, I moved the 5 out front, are you good? But then they do minus ln of 3 plus 2 ln of y. Why is that wrong? Yes, I would take it if you put parentheses here and you said all of this is in the denominator, okay? What they did was they distributed and said, these are both in the denominator, so you can do both of them as minus. Okay, you got to do one or the other, and that's the most common mistake on this quiz. All right, do you have this one? Oh. Let's do this one at least. I don't really care about that one because I feel like you're, oh, yes, I do. These are evaluate without a calculator questions. How could we evaluate log base 6 of the cubed root of 36? What could you do if I put that on the quiz? What is the cubed root of 36 mean? It means a power of what? 1/3. Then what could I do with the 1/3? So now I have 1/3 times the log base 6 of 36. Do you know what that is? 6 to what power is 36? Anybody awake? That would be what power? 2, right? 6. So we have 1/3 times 2 or 2/3 as the answer. All right. This one you could move the 9 out front and you have 9 ln of E plus you could move this 3 out front. There was already a 4 out there. Okay, but what's ln of E? Do you remember what that means? Yeah, well, it's 1 because it's E to what power? The base, right? This, hang on. Let me make that clear. This means log base E of E. So it's E to what power is E, which is 1. So we have 9 times 1 plus 3 times 4 times 1, which would be 9 plus 12 or 21. Did I do that right, guys?
So, I have a question.
Yes.
Can you technically ignore, not ignore, but can you technically say you not have to add in the multiply by 1?
Yeah,
And just go straight to
yeah,
plus?
yeah. Just as long as you remember that that exponent goes out front as a multiply. But yeah, ln of E is 1. Okay. So one more practice with no calculator. What is this? 3 to what power is 27? That would be 3 to the 3rd. Okay, and there was a 2 out front, plus 4 times, this is 3 to what power is 1/3, guys? -1. So this was a -1, and this was a +3, so we end up with 6 plus -4 is 2. Okay. Everybody all right? This is no calculator fun. Now we get to the expand ones. Before we attempt number 3 here, can we visit a slide I have that says this, okay? It says, watch out, the logarithm of a sum. When you have the log of a quantity, you cannot separate the quantity and okay, when you have the log of a sum or difference, you can't separate it into 2 separate logs, okay? Just like it's glued together when we want to cancel stuff, it's glued together here. Now, if that quantity, I started to say it wrong, because if that quantity was 2x, then we could separate it, okay? But if it's glued together with a plus or minus, you can't mess with it. All right, so back to question 2. This is going to be a mess. How many steps can we do this in? Log base 3 of, what do you want to do at the top? 5, and then?
The other 5.
Okay, so then we'd have a log base 3 of r to the 5th, but we're going to move that out. And it's times in here, so we're going to put plus 5 log base 3 of r. Now, we got this divide, right? So we're going to have minus a log base 3. But what is that? It's a t squared to the cubed root. What is that really as a power? Well, if you're, okay, hang on. You're all right, I think. It is a t squared to the 1/3, which if you multiply those is a t to the 2/3. Everybody okay? Okay. So we could write it as a t to the 2/3, and it was minus because it was divided, and then eventually we want to move that 2/3 out here. So it was, yes, that's as nice as it gets, okay? Well, that's why when it says expand, you don't do a ton of expanding in real life math. You would use it if you were, you needed to do some calculus operation like a derivative or an integral or something, because you might want to spread it out and that would make it easier. But in general, we use condensing a lot more when we're solving equations. All right, what about number 3 over here? It's just a base 10 log. What's the first one going to be? Yep, just the quantity a minus 2. We can't mess with it. But then it was times, so it's going to be plus. Don't forget to write the word log again. And then there's the quantity b plus 4. Do you want me to move this 6 out now or later? Okay, so that 6 can move out front. And then we have, we could move the 5, right? And then the log of b. Everybody okay? We moved that one out front as well. And we cannot make those parentheses separate because they were addition or subtraction. All right. This is a little practice on condensing. Anybody want to try this? I don't know that you have these, but where can I move that 12? And where can I move this 6? Okay. And then what does plus mean?
So you multiply 12 times y to the 6.
Where does that 12 go? Yeah, so it's going to be x to the 12th. The plus becomes times and y to the 6th. And you would not, if you just put x to the 12th, y to the 6th, I'd know you meant multiplication. The thing students struggle with sometimes is when they're all done, they forget there can only be a single log. I often get this. Okay? Does everyone understand why that's not correct?
That should be in the 1. Makes sense. Like parentheses a to 6.
Yes, it should be a single logarithm of. This is incorrect because it should be log base 7 of a to the 6th over b to the 12th. Everybody see the difference and okay with that? Any questions? All right, let's move on to the ones you have. Can you condense this into a single logarithm? Anybody got this one?
Yes.
Log base 9 of what?
Big parentheses, x minus 3 over 2x.
What?
Isn't the division?
It is division.
You put 11 as
Yet we need the 11 as the exponent.
divide that portion like that, like 2x to
Okay, I don't really like their. Do we need a negative 5th? That's what put it in the denominator, okay? Yes, definitely, I understand now where Destiny was going with a big parenthesis, because all of this is what we have, right? we could change this denominator. You do need the 2x, the whole thing is to the 5th, okay? So be real careful there. But I suppose someone could expand that and make it 32x to the 5th down there. I don't want to try to expand the top, do you?
Let's just say it's.
Yeah. Yeah. Okay, but do you remember you would have to write it out, you would end up with an x to the 11th and some x to the 10ths and some x to the 9ths and some x to the 8ths, and it would be a hot mess. Okay, moving on.
We say good enough, Ray.
Yes. Number 5.
ln to the 4th thingy where you get the square root. That
Okay.
makes sense.
So you want to write it
Up
as a 4th root.
with then a third out.
Yep. And you actually could put the 3rd power inside, or you could put the 4th root in parentheses and put the 3rd power on the outside. And then what?
Times 2h under the 4th root. Yeah, that looks fun. Also, can we
And-
technically put both of them under the same?
Yes.
root thing? Have
Because they're both 4th roots. Now what do we have though?
Just do 2h plus k to the 4.
Yes, let me finish what we got going on here. This is 2h plus k to the 3rd times another 2h plus k, so that's really what?
2hk plus
To the 4th. So what's the 4th root of that?
2h plus k.
The natural log of 2h plus k. Now, it's a miserable question, but what Brandon suggested was we rewrite it 2h plus k to the 3/4 here, and then plus means times, right? 2h plus k, and just leave it to the 1/4, because what do you do with exponents? Add, and that's 1. So we just would have ended up with ln of 2h plus k. That was a much easier way to think of it. We should have gotten the same answer, but it was a pain in the neck the other way.
This is fun. Let's see.
What?
This is like really hard.
Yes, it feels like really hard puzzles. I didn't put one like that on the quiz, okay, guys? But the quiz could look like this, I suppose. Do you have these two or no? This one is pretty basic. Do you need me to go through this? This one isn't bad, right? It's the log base 13 of 6 plus the log base 13 of A, and then you gotta move the 3 out front, plus the log base 13 of B, plus the log base 13 of C, and you gotta move the 4 out in front, but it's all multiplied. Let's talk about this one real quick, though. ln of 3y plus 2 minus ln of 4 minus still because it's in the denominator, guys. And how do you write that?
Y 1/3.
Okay. ln of y, the exponent is 1/3, so I can move it out front. And you do have to do that, guys. I don't want you to leave it the cubed root of y, okay? Can I mess with this anymore, though? Okay, the only other way you could have written this, guys, you could have said minus the quantity ln of 4 plus 1/3 ln of y. You could have said all of this is in the denominator together, and I would have accepted that, okay? Do you have these two? This is condensing. Oh my goodness, this is hurting my head. Where would this -5 go?
At the end of the.
Up here, which means it belongs in the denominator, right? And this 3 would go here. So we'd have log base 2 of x, it's times right now. But what would actually happen to that guy? So we'd have log base 2 of 6x cubed, and I'm not going to bother to cube anything, over x plus 1 to the 5th. Well, could you have figured it out? Maybe, I don't know. What's happening with both of these? Yeah, so this one is 3x plus 5 over, what goes down here in the denominator? Nope. We're condensing, so only one ln. This is x to the 4th. And this one is just the quantity x minus 1. But they both go in the denominator because they were both minus. All right. Change of base formula. And then we have a little more practice. Change of base is really just a typing question. It's when your calculator doesn't do it. Like your calculator does not do base 4, right? And I don't know 4 to what power is 72. It's not nice. The change of base formula comes from, let me show you, and then I'll teach you the little shortcut, okay? It comes from rewriting this as an exponent, 4 to some power equals 72, and then taking a log that you're comfortable with, that your calculator does, of both sides. So do you want to use LOG or LN? LOG? Okay. So if I take the log of both sides, now where can I move that little question mark box? So I have something, that was a weird box, times the log of 4 equals the log of 72. Now what could I do to find that something? Divide by the whole log. So I get the log of 72 over the log of 4. Now, I want you to type that. Close parenthesis. Okay. Log of 72, close parenthesis, divided by the log of 4, and that would actually close the parenthesis for itself. Then I want you to try ln. ln of 72, close parenthesis, divided by ln of 4. Okay? That's why it's called change of base, because we are evaluating a base 4 using either LOG or LN, and it doesn't matter which. Now, let's look at their questions. Rather than having to write this out every time, they say the formula is, look at right here, guys. You have this in your notes? It says it's the log of the big number divided by the log of the base, okay? So it's the log of x divided by the log of the base. So the base goes on the bottom. Can you remember that? So how would you type this? You could do log of 7 divided by log of 2, or you could do ln, okay? So this one you could do ln of 10 divided by ln of 1/3. So you have these. How are we going to type this one in? You want to do ln of the big number divided by ln of 32. Or you can do log base 10.
On the back of 60.
60. Oh, 60.
Okay, just remember you got to close the parentheses after you do the top. Okay? And it doesn't matter if you do ln or log. Now, let's go 3 behind the decimal. Can we do that? ln of 631 close parenthesis divided by ln of 32. 1.860. Anybody get for the first one? Okay. If you have the latest operating system, what was it again? 1.860?
Yeah, 1.86.
Okay, I'm gonna do one more and then I'll show you the trick. Log 47 divided by log, what was it on the bottom?
11.
Thank you. Weird base, huh? 1.606. Okay. Did the last one come out negative?
Yeah.
Anybody type the last one? What did you get? Thank you. If they have the latest operating system, your calculator does this for you. The old calculators and a general scientific calculator will not have a change of base, but these do. It is under math, and it is choice A. I did math and then up arrow, but it says log base, okay? And if you hit enter, then it'll let you type in that weird, what was that one? It was 11, and what number was the other? 47. Okay. Now, there is a shortcut. I don't remember where it is. It's alpha. Is it alpha 1? Alpha y equals? Yeah. Alpha window. Oh, there it is, number 5. So alpha window 5 brings it up. Otherwise, math button alpha A. Oh, so it's math, alpha math? So you got to decide which shortcut you like. Or you just use change of base, which is the way I learned to do them. All right, a little more practice. Who's got the first one? ln
2 ln
2 ln of x minus
ln 30.
yes, we have to remember the square root means 1/2 power, and so it's going to go out in front. And what do we do? Do we separate the 3x plus 2? No, we cannot. Okay. Oh my goodness. I don't know how much separating they want us to do here. Log base 2 of, well, if I just did 2x to the third plus log base 2 of x plus 1, okay, then I could move this 3 out front here, right? Is that really all the way separated, though? Because we can separate this multiplication, right? But both of those have the 3 out front, so be real careful if you separate that again, because that 3 went to both of them. I would not ask you one like this. You could say 3 parenthesis. Does anybody know what one of those simplifies down to? What's log base 2 of, ooh, sneeze. So sorry. Log base 2 of 2 is 1. So I could change that to a 1. And what could I do with that 3 out there? I suppose I could distribute it, would be a different way to write it, right? So I'd have 3 times 1 or 3. Plus 3 log base 2 of x plus log base 2 of x plus 1. I do hereby solemnly swear I will not give you that because there's too many different options for the answers, right? And I don't want to have to grade them all. Okay. Is that the one we just did? No, there's another one?
Yeah.
Okay, this one's not as bad, I think. Log base 13 of what?
3x
3. I would just do the 3, then what?
plus
Then the 4 in front of the next one, but the next one is times, so we can do plus. The 4 is only on the x. Is everybody good with that? That says 3 times x to the 4th. That's why I changed it to plus, and the x only goes on this, the 4 only goes on log base 13 of x. Then what?
minus
Minus, yes, this is a cube root, which is a 1/3 power. There we go. 7x minus 3, and we can't mess with that. We can't take the 7 away from the x because it's all part of the quantity, right? Oh, I forgot the 13, thank you.
I forgot the 13.
And I will tell you, on the quiz, if it had that and you forgot one of the 13s, I would not even blink. I would write it in for you. I'm not going to give you a 4 because, I mean, if you forgot all the 13s, I might, but
You forgot the 13 on.
yes.
Why would you put the parentheses around?
Okay, if it had in the denominator things that you were going to separate, which this does not, it's all one quantity. Okay, if it had in the denominator, for example, just a 7x, if it had said this, okay, I'm going to make an easy one. You would separate that to log 3 plus log y minus, and then you could say all of this is in the denominator together, log 7 plus log x, or you could distribute the negative because they're both in the denominator, so it is the same as saying because they're either a quantity that's multiplied or they're each separately being divided by. Okay, does that help? Great question. Oh dear Lord. Well, at least they're condensed. Is this the last of it? And then we got one more seismology question, but
And then to
real quick. What's the 1/2 power mean?
square root.
Okay, so I'm gonna have the square root on the top of 3x minus 5y all over
Oh, yeah.
the quantity 4x plus y, right? Everybody okay? That one wasn't really that bad.
So the other ones are just.
What about this one? This one is, why is there not a there's not a parenthesis because this 2 goes with, yeah, the x, this goes with back here. So it's this one squared. Okay. So what's the top? Log base 3 of 8 times x goes in the numerator, and then it's divided by the quantity x plus 4 squared. $14 log y times 3, right? Or 3y. Okay, we're gonna have a mess here. What's the denominator? Cubed root of x. Where does this go?
Good. Outside of the
It goes up top.
Why would they do that?
Well, it's plus, yes. Could we rearrange that and write all the pluses together if we wanted? There's no reason we couldn't, right? So it does go with the top. And it is a z squared.
Why?
Well, you got to know the difference. Only things that are minus go in the denominator, and that was not minus. Now this next one has a quantity that's minus, so both of those things back there go in the denominator, right? It's log base 3 of y times x, or xy, over, and what is all this? Times z to the third, and that was all in the minus. Now, I don't know why they did that, because that simplifies, doesn't it? Log base 3 of y over z to the third. I would have given you a different letter, but I could certainly give you one like that. I would not have made it simplified just because makes it confusing. All right, we have a minute left. I want to type these in real quick, guys. It is the log base 10. Base 10 is on your calculator as a button, right? It says use I sub 0 is 1. So it's just log base 10 of, oh my goodness, but what do they want? This is 6.7 equals, how do we work backwards to find that? Rewrite that.
Log base.
10 to the 6.7 equals, so what is the amount of energy generated by that? Somebody type for me. It's going to be a giant number. Clear.
Ooh, that's a 501, or wait.
That's how many kilowatts of energy? 50, 11, 872. 50, 11, 872 kilowatt hours of energy.
I have done, I wish I had the same.
Okay.
Very,
Oh, I wanted to do that example. Okay, anyway, remind me there's a warm-up tomorrow.
Is that the same one we had yesterday or?
This assignment is new and it's on the homework check sheets.
When do we get the review?
Either Friday or Tuesday. Yeah, it'll be here Friday if you're here, okay?